Okay, Consul-Terraform-Sync awesome use cases. So let me tell you a story. We've been doing a HashiCorp Vault project for a customer. And a customer asked for token-based authentication, which is super easy. And he also asked that all the connectivity will be encrypted and protected by mutual TLS. Now, we did some research and it's relatively easy to set up on Vault server and also pretty easy to set up on Vault agents. But when we started doing AWS load balancer, we actually figured out that it's pretty much not possible. And I will explain on that later, but the main reason is that when you want to do HTTP health check, you need to provide some client certificate and you can't. Now, we felt that there's no way to solve it, but then Consul-Terraform-Sync actually saved the day. So I'm Lev, and I'm CTO at TeraSky, and I've been Linux sysadmin since 2000, and I'm one of the HashiCorp Ambassadors, and I really love weird mechanical keyboards that looks like that, all right? And let me tell you about TeraSky. So we are a consulting company. We part of a cloud native compute foundation, and we invest heavily in Kubernetes, and we are HashiCorp partners, and we help our customers to identify and implement the right combination of technologies so they can migrate to cloud with cloud native software, and we help them manage scalable and secured platforms. So what are we going to talk about today? So first of all, we're going to introduce Consul-Terraform-Sync according to documentation. Then we will discuss what it can actually do. Then we will cover multiple use cases, and we will wrap it up. So Consul-Terraform-Sync, right? So let's talk about the Consul part. Now, Consul can do three main things. It can do service discovery, it can do service mesh, and it can do key values, right? So service discovery is just a brief idea, right? We can have our server that is running microservice A. And this microservice A will register itself into Consul server. And now Consul server will know that there's microservice A running on that IP. All right? Then we can have additional server that is also running microservice A that can register itself. And Consul server will know that there are two microservice A running on those IPs. Okay? Now the third server will run microservice B. When it registers itself, it can actually go to Consul and ask for microservice A. And he can ask for it through REST HTTP API, or it can just do DNS query and get a response, and then it can communicate with microservice A. All right, so this is just a basic idea of service discovery. Now, in Consul, in addition to having those service discovery capabilities, you also have agent that is running on the server, and it can do health checks. And those health checks can be anything from TCP, HTTP that are standard, or custom script that can check your CPU memory utilization or access to the internet, right? And decide what is the health according to that. So Terraform, and I hope everyone here knows what Terraform is, so let's just do it quickly, right? It's infrastructure as code or as config. It allows you to declaratively define infrastructure, but not only infrastructure, and I will show you in a second. The awesome part is that it knows how to build dependency graphs, right? So you can write your files and resources in whatever order you want, disks, load balancers, I don't know, routes, and Terraform will actually understand what is dependent on what and deploy it in the right order without you explicitly specifying it. Now, it's also state aware, and this is the second awesome part of Terraform, so it only does what it has to do, right? It's if part of the resources already created, he will not create them again. He will just say, okay, this is fine, let's just do that. Now, those are the providers that Terraform can handle, right? So none of them is explicitly infrastructure, right? GitLab users and repositories that you can create with Terraforms, Grafana dashboards, CodeFresh pipelines, or deploy your application into Kubernetes. All right. So Consul-Terraform-Sync works like this. You would have your software that can, horizontally scale out, or a server can go down, and this will update Consul. And Consul will actually be connected to Consul-Terraform-Sync and will update it with the required change. And Consul-Terraform-Sync will trigger Terraform that will configure the firewall with the required changes, right? So it sounds like it's mainly around networking. Now, if you take a look at the documentation, it literally calls it network infrastructure automation that enables dynamic updates to the network infrastructure devices triggered by service changes. Okay. Now, the use cases for CTS is actually around application teams that want to move fast and deploy their stuff, but they need to wait for networking and security teams to slowly configure their load balancer and firewalls and intrusion detection system to make the changes, right? And if you take a look at the GA partners of CTS, you will actually see that most of them are networking and security companies. So let's see what it can actually do. So on startup, Consul-Terraform-Sync just pulls the Terraform, right, the binary, because it needs to do Terraform apply, and it pulls any module that you specify. And it doesn't have to be network related. It can be Grafana dashboards. Now, during runtime, it will connect to Consul, and it's actually doing something smart, right? It has those blocking queries in Consul, so it will connect to Consul, and it will wait until the change happened. And when the change happened, it will actually take all the data, generate terraform.tfvars file, and it will provide it to our module and do Terraform apply. This is the whole idea, right? So it connects to Consul. When change happens, pulls Terraform, pulls the data, populates Terraform.tfvars, and does Terraform apply. How do we configure it? Super easy. This is the global configuration file, right? So you will have log level, you will have your port, so you can check task status, you can specify how you want to send data to syslog, and the buffer period is awesome as well, because if you can have like a flapping, right, of your service, which will go down and up and down and up, you can actually wait minimum and maximum time until you decide, okay, now it's stable, so let's take the data now and actually do our magic. Now, this part is how do we connect to Consul itself, right? What is the console that we need to pull data from? And the task. This is the magic. So it has the name of the task and it has the description of the task. And then you specify the module that you pull, right? Like calling a module, just a source. And the condition is actually what is the change that you are expecting, right? So in our case, the condition, we're checking services and it supports regular expression. So you can either wait for specific service or you can wait for just anything that matches the regular expression. And then you have the driver that is actually executing the change. And today there are two options. It's Terraform or Terraform Cloud. So you specify if you want log and your backend, right? And probably want to have it as a remote backend and not local. So the whole Consul-Terraform-Sync will be stateless. Now, how do you run it? Super easy, as everything in HashiCorp is just one binary that you execute, you provide a configuration file, and you're done. And then you will have this tree created, right? And the name of this directory will be called as the name of your module, of your task, sorry. And you will have a main TF that will actually say, take this Terraform.tfvars and additional variables file if needed, and just run the module that you specified previously. So that's the whole magic, right? And the Terraform.tfvars, once a change occurs, looks like this. It's just it's a map of services, and each service is just an object that will contain like ID and kind and address and port and tags and just everything that Consul will have about that. All right, so in order to be able to handle these Terraform.tfvars, this map of services, you just need to include in your module, in your variables, this variable of services, right? So it just expects a map of objects. All right, so let's talk about use cases. Now, the first one, it's not very realistic, but it's just an idea. About 4 months ago, Andre Wood and me, we were doing a workshop for Zero Trust, right, with HashiCorp. And what we did during the workshop, we set up HashiCorp Cloud Platform, and we set up a Vault and Consul in HashiCorp Cloud Platform, and we set up in AWS VPC, EKS, deployed MySQL and some software into it. Now, Consul has this awesome tiny feature that's called catalog sync, and this is why I love the ecosystem, because everything is integrated and everything works great together. So catalog sync actually takes all the services from EKS and it syncs them into Consul and vice versa. So you can synchronize all your services from Kubernetes to Consul and back. Now, the other thing that we also did is we introduced HashiCorp Boundary, and I hope you've been checking this project because it's amazing. It's like alternative to VPN, but it's a million times better, right? So it's actually configurable through Terraform. So you can specify all your services, where they are, and then being able to connect to it. Now, what we did is after all the services were synced to Consul, we triggered Consul-Terraform-Sync that actually configured Boundary, right? So at the moment where we were creating this workshop, the idea of dynamic host catalog in Boundary didn't exist yet. It was just something that planned. And today there are 2 dynamic catalogs, right? So Boundary can actually find hosts in Azure and hosts in AWS. And in the roadmap, Boundary will be able to find also hosts in Consul and Kubernetes, hopefully. But today, you can actually use this idea that I'm showing you to actually have it already today, right? So what we did again, we had our Kubernetes syncing all the services to Consul, and on any change, Consul-Terraform-Sync will just configure Boundary so you can have your VPN that is constantly updated according to your pods, and you can always connect to them. And then we would just take our Boundary desktop and show to that we can connect. Now, this is a part of the module that configures it, right? So Boundary host is like a service, right? In our case, I just iterated over services and created like MySQL service, software service, and so on. Then you would have your Boundary hosted, and this is like each pod that has an IP, or each host that is actually part of this service, right? We will create a Boundary hosted. So I've iterated over my services and just populated all the hosts or all the pods into that host IDs. And the last part is the Boundary target, right? This is how you connect actually to your pods. So Boundary target needs a host source IDs, right? So this is the guide that we created before, and explicit port. So I'm just checking if this is MySQL, and if it's MySQL, I'm just adding this host set here and specifying the port. That's it. So every time MySQL will be redeployed, or it will change, or the pod's IP will change, it will be updated and it will be reconfigured in Boundary automatically. So the awesome part about Boundary also is this part. So in addition to giving you specific access to specific service that you need, it can also generate username and password on demand with Vault, so you can have your on-demand credentials to your service. Super awesome stuff. Now, this is the repository of the workshop that we used. Don't use it in production. It's just an idea, or kind of just for the reference. But yeah, so this is the use case. Second use case is Palo Alto Prisma runtime policies. So I don't know if you're familiar with this product. It was called Twistlock, and Palo Alto purchased it, and now it's called Palo Alto Prisma Compute. And what it does, it's a container protection solution, right? So it can protect your Kubernetes, your Dockers, and in addition to standard stuff like checking your malware or checking your vulnerabilities, it can do something smart. So let me explain about it. If you can see, it's our default namespace, and in our default namespace, I've deployed a boutique store demo application. So you can see it's ad server and currency server and email and so on. So what Palo Alto can actually do, it can learn what a container is doing. So it will learn what kind of processes are running in the container, what's networking that a container is doing, what are the files the container is accessing, right? What Linux capabilities are happening there. And after learning period, Palo Alto will know that this is the container and this is what it should do. And everything else is, you can either alert on everything else or you can prevent anything that is anomalous. So the customer actually wanted to have an explicit specification of DNS rules, of DNS addresses that are always allowed. It doesn't matter what Palo Alto learned, those are always okay. So this is what customer wanted. And in Palo Alto, there are two policies that you can configure. You can configure it both for your containers and both for your hosts. And it's kind of duplicate management of the same thing that customer didn't want to do. So, everything CTS to me. So I was, looking for a solution through CTS. Now, this is an example. This is what this runtime rule looks on host. Pretty much the same. So I checked for a Terraform provider, and it was, because Palo Alto actually cover most of their products with Terraform providers, which is great. And Consul, as I've mentioned, has this feature of key values with this awesome UI that users can just connect to, and they can authenticate with tokens and they can edit it. So this is super convenient. I've created this key value called allow DNS with DNS 1, 2, 3, and you can actually see the value that it's yahoo.com. And this is my configuration of CTS, right? So if you remember, in the previous example, I showed you that the condition is services. Now, in this case, the condition is Consul key value, and this is the specific path that I'm searching for, and I'm recursively going to search all the keys inside of that path. All right. Now, in addition to this part in my module that can handle services, I added this part that actually handles Consul key values, right? So it's just map of strings. And once I added values, this is the terraform.tfvars that was generated for me. So it's Consul key values, and you can just see that it's allowed DNS 1, 2, 3 with their values. So what my module looks like is super simple, as you can see. If it's empty, I ignore it, and if it's not empty, I will just populate it in this array of allowed DNS. That's the magic. Then I would just have my resource of Prisma Cloud Container Runtime Policy, and I would just provide my local allowed DNS, and this would be for containers, and exactly the same policy for hosts, right? I would just provide allowed DNS for local allowed DNS. That's it. Exactly the same configuration for two different policies managed from the same location from UI, super easy. And as you can see here, this is the explicit allowed DNS rule that I've created and populated with some DNS values. All right. So MTLS for ELB, right? This is the third one. So this is the story that I initially told you, that we had Vault clients, right, that needed to be connected to those Vault servers. And we wanted to have load balancer in the middle so it can load balance among healthy Vault servers. Now, the problem is that we even went to do TCP pass-through, which is fine, right? And TCP pass-through should give us these MTLS abilities. But we still want to remove invalid, not healthy servers. And we wanted to we wanted to actually do access to this path to check whether Vault server is healthy or not. And load balancer cannot access to Vault server once MTLS is enabled on Vault server. And this is not a Vault problem, right? It's a general MTLS issue for ELB. Right. So, what we found is that in Vault, and again, all ecosystem is working great together. So in Vault, there's this service registration stanza that actually can register our Vault into Consul, right? So you know where I'm going with it. Now, our Consul cluster will be running, and our Vault server would be registering itself. And every time there's a change, it will actually update Vault cluster, and Vault cluster will update our Consul-Terraform-Sync, and Consul-Terraform-Sync will update our target group. So it will remove the non-functional server from the load balancer, right? Now, we try to solve it without this complexity, right? Initially, we said we will just run maybe local scripts that will check locally the health of the server, and it will update Route 53. But then we hit another problem, right? If we went with Route 53, we would either have a very low TTL and a lot of DNS queries, or we would have a long TTL, right? But then we can actually hit non-functional servers with this long TTL. So we tried to solve it, but this was actually the best highly available solution that we found, and this CTS is pretty much stateless, so it can, fall and we can get a new one, and it's a pretty resilient solution. All right, so this is our configuration of the CTS, right? And this is the console address, and we're just using this module to configure our load balancer, and we're waiting for Vault service, and we're using AWS provider, and this was just for POC, right? So it's a local backend, but eventually we went for something central, and this is the terraform.tfvars that we've got every time that Vault health changed, right? So this is what we did. We actually created the targets, and we went over our VAR services, and we just populated, target ID and the port with, a service node address, only if the status of the service is passing. So that's it. Everything that is passing, we just populate it into target, and then we would just use NLB, right? The standard module from Terraform registry, and our TCP would be, TCP listener would be TCP, right? Because again, we don't need to health check anything on load balancer level. And our target group, we would just populate the targets with local targets that we created earlier. That's it. That's the general idea. So you saw those three cases, but there's way more, right? So just some ideas for you. You can do console to config maps, right? So you can, for example, if you want to update your, log level to debug, you can update it in console, and through a Kubernetes provider, you can update it in your Kubernetes. You can manage AWS tagging, and actually Nico has a Medium blog on that, so you can check it. It gives like a basic idea on how you can centrally manage those things. And for example, if you have two console servers and you want to replicate a part of them, and only when something is changed, and in a smart way, so you can do console to console replication with Consul-Terraform-Sync, right? So those are some of the ideas. And again, so CTS is way more capable than just management of firewalls. So consider using it. CTS is event-driven, right? So it's not like our usual flow of Terraform. It's proactive, right? That we know we need to set up EKS, so we're doing Terraform apply. You can, do day two operation that are pretty much smart and automatic for anything. And Terraform is not only infrastructure, as I showed you, right? It can be whatever you want, including ordering pizza. And events are, again, not only service up or down, right? It can be key values, but also your health checks can be super smart, right? So you can say, if I'm lowering, if I'm stopping health for my service, maybe it's a DDoS, so I will do something on that level, or increase my auto-scaling group, or I don't know. But there's a lot of logic that you can do once you have that ability. So this is Consul-Terraform-Sync awesome use cases. Thanks a lot.